Assignment number 4, Passive House Energy Benchmarking, Allen R. Benaventura. So my case studies about energy benchmarking to study the energy consumption of NHA housing unit. The housing unit is attached to another unit as a duplex residence. The NHA single unit is approximately 29.58 square meters. The residence will house a typical family of 4, 2 parents and 2 children. And the housing unit will have living, dining area, kitchen, bathroom, and loft bedroom. The case study will use several case study scenarios. The process of benchmarking will be based on product selection, the user-driven energy saving initiative, and benchmarking will maintain the ideal performance level of residential dwelling. The study will analyze energy consumption of the duplex residence per day, per month. The kilowatt hour of power consumption will be evaluated. The final strategy is to achieve passive house design reference to energy consumption. So the objective of the study is to identify the following. Identify poorly performing residential duplex electrical design, establish a baseline for measuring improvement in energy consumption of the residential duplex, enhance and create competition through comparison with several electrical design setup, and create a model design to accomplish the passive house design criteria. So the benchmarking process will be product selection. The study will use electrical devices selection as part of the strategy to lower energy consumption of the residence. The study will also use strategic use, user-driven energy saving initiative as part of the study. The benchmarking process will also use performance-based. The study will maintain the ideal performance level of the residential duplex. The study will analyze energy consumption of the duplex residence per day and per month. The kilowatt-hour power consumption will be evaluated. And the final strategy to achieve passive house design in reference to energy consumption. So in passive house, the product benchmarking will be the materials, which is to compare the use of incandescent bulb to LED lights, which is about the LED lights about 90-95% less power compared to incandescent bulb. The illumination is almost the same. It was observed that proper selection of energy efficient light bulbs can lower power consumption. In energy benchmarking on small appliances, this is to compare the non-inverter and inverter motor driven appliances like electric fans, refrigerators, washing machines. And it is concluded that the inverter type consumes less than 20 to 43% less power than non-inverter small appliances. The energy efficient appliances like television, radio, laptop consumes about 37 to 40% less power than regular small appliances. Strategic use. So in this study, the user strategy is power saving are compared to regular hours calculation based on electrical code. The use of small and large appliances and lighting are tabulated in terms of hours used per day. The user will observe proper utilization of power by monitoring daily use of electrical lights and small appliances. It was observed that you can save 17% from the total time per day using energy saving strategies. It was observed by energy saving strategies can lower power consumption. So in case study number 1, so the standard design with non-inverter motor load. So this is the typical load of a residential dwelling, about 29.58 square meters. The volume is about 70 cubic meters. So the cost per day is about 47.28 pesos per day of a kilowatt, and average cost per month is about 1,480 per day. In pesos is about per month in pesos is about 1,400. Per day in pesos is 1,418. In kilowatt hour per day is about 313.42. The kilowatt hour per month per unit is about 402.60 kilowatt. No? per unit. So the per day is 13.42 kilowatt. So in using non-inverter motor load user-driven strategy, in this case study, the typical design of an 29.6 square meter dwelling will use strategy-driven energy use. So the energy consumption was lowered to 10.53 kilowatt hour per day from the 14 kilowatt, the previous consumption of 13.42 kilowatt. So the 3 kilowatt energy consumption was less, no? So there is a case study too, which is using inverter motor load and LED devices. So this is the area is similar to the case study one, but using a inverter load, inverter motor appliances, small appliances, and motor-driven appliances. And this lowered down the energy consumption to 7.39 kilowatt hour per day. So it is almost half of the consumption of the non-inverter motor load and non-LED lighting fixtures. So in the user-driven analysis, so it is a strategy. So the using of non-inverter inverter type motor, inverter motor type appliances and LED devices, and combining it with user-driven strategy. So the consumption was lowered to 5.47 kilowatt hour per day. So from 14 kilowatt hour to 5.47 kilowatt hour per day. So this was there is a significant reduction of energy consumption. So the case study analysis, so in conclusion, the case study 2S, the design uses LED lighting fixtures. Energy efficient small appliances are specified to use by the owner, and other small appliances uses inverter motors. The energy consumption is driven using energy efficient strategies. So the design resulted lesser energy consumption compared to the case study, to all case study that was presented. So in benchmarking, we can see that the energy, this is based on the Green Building Code survey, so issued by the Department of Energy. So this is the energy utilization index comparison in kilowatt hour per square meter per year. So in residential condominiums, so you can see that the Philippine base, there are several types of benchmarking that was compared to the case study. So this is the for residential condo based on IFC PGBI survey 2013. It's about 65 kilowatt hour per square meter per year. So this is the another is 65 for the building edge Philippine baseline, 65. For the Philippine GB code, it's 43. For the zero code derived from ASHRAE, it's about 136. So if we will compare our case study, so this is the case study area, which is about 29.58 square meters. So our kilowatt hour per month is about 402.60. So if we will multiply the Philippine Edge, Philippine GB in the zero code or the ASHRAE to the area that we have, so it is concluded that you can see that the all of our case study 1 to 2S complied with the zero code ASHRAE. In Philippine GB code, case study 2 and 2S meet the Philippine GB code compliance. In the case study 2S, it is equal to the Edge Philippine baseline. So in using renewable source of energy, so this is the The case study will use solar energy using photovoltaic cells applicable in tropical climate. Solar panels in the Philippines today are even more efficient in generating electricity, mostly because of the country's geographical location being close to the equator. So solar or photovoltaic cells are made of silicon or other materials that transform sunlight directly to electricity. So it doesn't produce pollutants, and it has lesser environmental impacts beyond the manufacturing process. So the study will use 500 watt solar panel for the design analysis. Its panel has 144 cells and 25 linear year power product warranty. The size of each panel is about 1.132 meters by 2.274 meters, which is almost the same size as a plywood, and the thickness about 35 millimeter, with approximate weight about 29 kilogram each panel. So as you can see in the case study, so the case study 1 shows that you need 33 solar panels to energize the 13.42 kilowatt hour per day consumption. So the 33 solar panels need 95 square meters roof area. So case study 1 is not feasible for solar energy. So in case study 1S, the result shows that 26 solar panels are needed to energize 10.53 kilowatt per day consumption. So the 26 solar panels needed needs 74.88 square meters of roof area. So the case study 1 is not feasible for solar energy. So no, the case study 1S is not feasible for solar energy. The case study 2 shows that 18 solar panels are needed to energize 7.39 kilowatt hour per day consumption. So the 18 solar panels needs 51.84 square meters of roof area. So case study 2 is not feasible for solar energy. So in the result shows that 13 solar panels are needed in case study 2S to energize the 5.79 kilowatt hour per day. So the 26 solar panels needs 37.44 square meters of roof area. So the building, sorry for the typographical error. So the case study 2S is feasible for solar energy because our roof area is about 36 plus square meters. So it's feasible for solar energy power. So I'll just edit the conclusion on the last part of this slide. Okay, so in the energy efficiency realization, so the energy saving devices and energy saving strategies, using the user-driven strategies, can create a lower energy residence, and the result will have energy efficient residence. You can use also renewable energy, and you can have a longer devices lifespan or low operational costs. Thank you.